Electrical safety. Electrical safety and you. It's hard to think of a job today that doesn't involve the use of electricity. Some workers, like engineers, electricians, and people who do wiring, work directly with electricity. Workers in an office or a restaurant staff use electricity indirectly. Working with electricity can be deadly if it's not done safely. With every electrical equipment operation, there is a chance of getting electrocuted. Restaurant employees face hazards and dangers every day when working around electrical equipment, especially in commercial kitchens. There are many electrical hazards in commercial kitchens because of the many different electrical appliances in use. Restaurant workers might be in danger of electrocution, shock, or even death from unsafe work practices, bad or faulty electrical equipment or wiring, or when using damaged receptacles and connectors. However, proper training and education about safety and the correct work practices when working with electricity or electrical equipment can eliminate most hazards. The hazardous situations that cause the biggest threats are incorrectly used or damaged electrical cords, wet areas and improper cleaning practices, faulty wiring or equipment, damaged outlets and connectors, overloaded circuits or outlets, improper grounding, overhead power lines, exposed electrical parts, damaged tools and equipment, defective insulation, improper or lack of personal protective equipment. Common electrical hazards are electric shock and electrocution. These can occur from contact with faulty electrical tools and equipment, faulty appliances and wires, electrical outlets, switch panels, electric transformers, overhead power lines. How electricity works. Think of electricity as water in a garden hose. You need pressure to make the water come out of the hose. Without pressure, no water will flow. At the end of a hose, a nozzle can be added to turn it off. The pressure is still there, but the flow stopped. This is similar to the electrical switches in a school, house, or workplace. When you turn off a light, the flow of electricity stops, but the electrical power is still there. The pressure of an electrical current is measured in volts. It doesn't take much current or flow of electricity to injure or kill. 75 1/1000ths of an ampere, the amount of flow needed to light a Christmas tree light, can kill you if it goes through your chest. An electrical shock can affect your breathing, heart, brain, nerves, and muscles. The body has its own electrical system for breathing, nerves, and heart rate. An electrical shock can shut off or blow fuses in your body, which can be deadly. When your fuses are blown, your heart can stop, and so can your breathing. A fatal shock is called electrocution. Electrocution is one of the leading causes of death of young workers. Contact with overhead wires is another common cause of electrocution. This can happen when people are carrying ladders, poles, or using equipment that is tall enough to touch the wires. Electrical shock. Electrical shock occurs when electricity enters your body. You become part of the electrical circuit or system. Electricity always seeks the shortest path to the ground. If you're part of the path, the electric current flows through you to the ground. The flow or amount of electricity, amperes, and the length of time your body is in contact with the electrical current determines the amount of damage caused. The strength or voltage of the electricity affects the amount of current, but electricity can cause serious injury or death at both low and high voltages. Scenario: electrical safety in the restaurant. An 18-year-old worker with 15 months of experience at a fast food restaurant was plugging a toaster into a floor outlet when he received a shock. Since the restaurant was closed for the night, the floor had been mopped 10 minutes before. The restaurant manager heard the worker scream and went to see what happened. The worker was found with one hand on the plug and the other hand grabbing the metal box receptacle. His face pressed against the top of the outlet. The manager tried to take the worker's pulse, but got shocked when he touched the worker. The manager couldn't locate the correct breaker to shut off the circuit. He called 911, returned to the breaker box, and found the correct breaker. By the time the circuit was turned off, the worker had been exposed to the current for 3 to 8 minutes. His pulse was extremely rapid at this time. When the emergency crew finally arrived, the worker had no pulse. Even with CPR, he was dead on arrival at the hospital. The exact events that resulted in the electrocution couldn't be defined with absolute certainty. However, investigators concluded that while the victim inserted the plug of the toaster into the receptacle with his right hand and held open the grounded metal receptacle cover with his left hand, his index finger touched an energized prong of the plug, causing him to receive an electrical shock across his chest. What could have been done to prevent this death? Employers have the primary responsibility of protecting the safety and health of their workers. Make sure every employee is trained on the procedures during an electrical emergency. Show everyone how to shut off the power in an emergency. Use ground fault circuit (GFCI) receptacles and outlets. Keep power cords away from liquids and equipment when they're in use. Don't use faulty or damaged equipment, receptacles, or connectors. Don't plug in electrical equipment with wet hands or when touching a wet or damp surface. Don't pull on cords to unplug equipment. Only use extension cords temporarily when needed. Employees are responsible for following these safe work practices from their employers. Emergency procedures and policies in the workplace. How to shut off the power source, electrical current, or breakers in an emergency. How to correctly perform CPR. To pull the plug, not the cord, when unplugging equipment. To keep power cords clear of equipment during use. To use sealing plugs rather than draping cords across aisles. Not to touch a worker being shocked until the power is turned off. Not to use faulty equipment or damaged receptacles and connectors. Not to plug in electrical equipment when touching wet or damp surfaces. Not to use cords that are worn or damaged, or cords that feel warm during use. Warm cords have the potential to start a fire. Use a cord that has a capacity to use a higher volt power, or a multi-outlet power strip unit with a built-in circuit breaker, instead of an extension cord. Don't use equipment cords that are warm during use, and have them checked by an electrician. To report unsafe equipment and work practices to your employer immediately. What should you do if someone is shocked by electricity? If you see someone who has been shocked by an electrical flow, do the following first. Disconnect the power source, call for emergency services or 911. Do not touch the person until you are sure the power is off and they aren't part of a live current path or flow. If you touch the person, you might be electrocuted and the next victim. You should not administer CPR or first aid until you know the power is disconnected and you are properly trained in these practices. Other electrical hazards. In addition to electrical shock, contact with electricity can cause other problems. It can throw you or make you fall. If you get an electrical shock when operating a power tool, you can lose control of the equipment, which can injure you or someone nearby. Grounding. Proper grounding of electrical equipment helps prevent electrical shock. An ungrounded power tool can lead to electrical shock, injury, or death if enough electric current passes through a body. Grounding provides a safe pathway for electricity to travel from the equipment or circuit to the ground, preventing shock. The third prong on a plug is the ground prong and should never be removed. Double insulated tools labeled with the words double insulated or double insulation do not need to be grounded. A ground fault circuit interrupter, GFCI, is an inexpensive lifesaver. A GFCI detects current leakage from a circuit to a ground and shuts the current down. For example, if there's a short, current leakage, in a power tool, the metal casing can become live, which can cause a shock. A GFCI cuts off the power before you get seriously shocked. There are three types of GFCI. A GFCI receptacle, a portable GFCI that plugs into a standard receptacle, a GFCI circuit breaker. Because water is a great conductor of electricity, GFCI electrical sockets should be installed and used in all areas where someone works outdoors or in wet areas such as a kitchen or bathroom. Equipment needs to be grounded in any of these situations. The equipment is within 8 feet tall vertically and 5 feet wide horizontally off the ground or any walking surface. The equipment is within 8 feet tall vertically and 5 feet wide horizontally off grounded metal objects you could touch. The equipment is used outside. The equipment is located in a wet or damp area and not isolated. The equipment is connected to a power supply by a cord and plug and is not double insulated. The third prong in portable tools and extension cords provides grounding. What is lockout-tagout? Lockout-tagout refers to the specific practices and procedures that protect employees from machine injuries or electrical shock from an unexpected energizing or startup of machinery and equipment during service or maintenance activities. Hazardous energy includes electricity as well as other forms of energy like mechanical, hydraulic, and pneumatic. OSHA created the lockout-tagout regulation to prevent deaths and serious injuries from unsuspecting workers being caught in machinery or contacting live electricity while doing repairs or servicing equipment in general. Lockout-tagout methods require that an authorized person, someone trained and allowed to do so, turns off and unplugs the machinery or equipment from its energy source before starting service or maintenance procedures. The authorized person must lock or tag the energy isolating device to prevent the flow of hazardous energy and takes the proper safety steps to ensure the energy has been correctly isolated. Lockout includes using locks to ensure circuit breakers, switches, valves, etc. are held in the off position or not operated until the authorized person who attached the authorized device removes it. These lock devices can only be removed with a key or other unlocking device by an authorized person. Before the locks are removed and the equipment can be powered on, everyone must be in a safe place and be in attendance. Tagout involves using tags to warn others that a circuit breaker, switch, or valve and the equipment it's attached to must not be used until the tag is removed by an authorized person. Because a tag only serves as a warning and does not physically prevent equipment from being started, it's much less protective than a lockout device. Tags are only to be used in conjunction with other safety procedures that provide protection equivalent to lockout devices. Summary: electrical safety do's and don'ts. Electrocution can be prevented if employers and employees are properly trained in safety procedures and follow these do's and don'ts. Do's: know the safety procedures for electrical emergencies. Know how to shut off power in case of an emergency. Know how to correctly perform CPR. In any emergency, 911 should be called immediately. Keep power cords away from heat, water, oil, and sharp edges. They can damage the insulation and cause a shock. Switch equipment off before you plug it in or unplug it or make adjustments. Pull the plug, not the cord, when disconnecting tools or equipment. Cover any open electrical outlets with plastic safety plugs. Install and use ground fault circuit, GFCI receptacles, and outlets in all areas where someone works outdoors or in wet areas such as a kitchen or bathroom. Check that guards and other safety devices are in place before turning on and using a machine. Keep hands, face, hair, clothes, and jewelry away from moving parts. Use extension cords only with the right ampere or power wattage ratings as the tool and outlet, to temporarily supply power to an area that does not have a power outlet. Keep power cords clear of the equipment during use. Suspend power cords over aisles or work areas to avoid tangling connections and stumbling or tripping hazards. Inspect equipment, power cords, electrical fittings, and outlets for damage before every use. Have damaged equipment repaired or replaced. Any equipment or cord that feels uncomfortably warm or very hot should be checked by an electrician. Ensure that electrical equipment is correctly grounded or double insulated. The grounded equipment must have an approved 3-wire cord with a 3-prong plug. This plug should be plugged in a correctly grounded 3-pole outlet. Test all electrical equipment for correct grounding with a continuity tester or a ground fault circuit interrupter, GFCI, before use. Report any damaged tools and equipment or ones that give minor shocks to your supervisor immediately. Report exposed live parts as well. Use a lockout-tagout system. Locking devices and/or place a written warning on the power source of appliances that aren't working or being repaired. Don'ts. Touch someone who has just been electrocuted without turning off power and circuit breaker first. Pull or jerk on cords to unplug equipment. Always grip the whole plug. Touch, plug, or unplug electrical equipment with wet hands or while touching or standing on a wet or damp surface. Use electrical tools or machines in damp or wet areas unless the equipment is connected to a GFCI outlet. Always keep equipment cords out of puddles and wet areas. Avoid the switch and operate tools by connecting and disconnecting by the power cord. Turn off power switch first, then unplug. Carry electrical tools by the power cord. Tie power cords into knots. Knots can cause short circuits and shocks. Loop the cords or use a twist lock plug. Overload circuits and outlets by plugging several power cords into one outlet. Put fingers on the prongs when inserting into outlets. Use a broken 3-prong grounded plug with the third prong broken off. Always plug a 3-prong plug into a properly installed 3-prong socket. Use extension cords as a permanent solution. Allow carts and trolleys to pass over unprotected power cords. Cords should be put through a tube or protected by placing planks on them. Use tools or cords that get very warm or hot. If you get shocked, immediately report the incident to your supervisor. Use faulty or damaged equipment, receptacles, or connectors. Repair faulty or damaged equipment yourself. Leave that to a professional or someone who is trained to do so. Use metal ladders when using electrical equipment or electrical work. Clean electric equipment and tools with flammable or toxic substances.